next type of reaction is the decomposition reaction. We can demonstrate this reaction when we heat potassium chlorate. When we heat potassium chlorate, it will decompose or break itself apart into solid potassium chloride, a salt, and oxygen gas. You can see that I've set up a test tube containing potassium chlorate, and it's stoppered off with a long tube that is then submerged into water. As we begin to heat the potassium chlorate, the gas expands, causing some small bubbles to form. Then those bubbles start to slow. What then starts to happen is that the potassium chlorate turns from a solid into a liquid as the intense heat starts to melt it. The small bubbling that you see occurring is again just because the gas inside the tube is just expanding. But we'll want to notice what happens is that next we'll all of a sudden see the reaction start to take place. All of a sudden, you can see bubbles start to emerge from the liquid, and more bubbles rapidly start to come out of the water. That's because we have reached the point where the decomposition is occurring. Oxygen gas is now being released, and potassium chloride is starting to form in the test tube. This process will continue to produce the products until all of the potassium chlorate has been decomposed, and all we're left with is solid potassium chloride in the test tube, and all the oxygen gas has been dissipated. Now that all of the potassium chloride is gone, we have just the residue of potassium chloride left. So let's break down the basics of what a decomposition reaction is. You may have noticed that it's essentially the backwards reaction of a synthesis reaction. Instead of forming a more complex substance from more simple substances, we're breaking down a more complex substance into more simple substances. Here we start with a compound, AB, and that more complex compound becomes ripped apart into more simple substances, A and B. We can watch how this unfolds in the particle diagram. As the reaction begins, compound AB separates into more simple substances A and B, forming our products. Let's look at the overall process along with the reaction shown. Now let's take a look at what this will look like for the reaction that we saw in the demonstration for the decomposition of potassium chlorate. For the reaction of the decomposition of potassium chlorate, it's important to understand that we always start with a single compound. Again, we want to understand that we're talking about a single type of compound, not necessarily that in our balanced reaction you will have two quantities of that single compound. In this case, we have two potassium chlorates, but the compound we're discussing is just one compound, potassium chlorate. What we'll see is that whenever we have a decomposition reaction, we always break apart one type of compound. When we watch the particle diagram take place, we'll notice that this compound breaks apart into two less complex substances. In this case, an element and another compound. As the reaction unfolds, the potassium chlorate breaks apart into a compound, potassium chloride, and an element, diatomic oxygen. These substances are more simple than the original substance, the compound potassium chlorate. Let's go ahead and look at the overall process along with the balanced reaction to get a big picture overview. We have a more complex substance being broken apart into more simple substances: potassium chloride and oxygen gas.